What's up everybody, welcome back. So part 7 in the AI card tutorial, and today I want to take a look at setting up our first EQS query. So currently if the guard spots us, he's going to move towards our location and he's just standing there. So we're going to make him investigate that location and to make sure he's not facing a wall or just staring inside a corner or things like that. We're going to use EQS so we can get a bit more information about the level and actors and things like that around us and make a decision based on that. So that's what EQS is used for. You can get information about actors, the level, all kinds of things by doing queries and tests. And we're going to get into that a little bit later. So it's not going to be a too complicated EQS query, and we're going to make multiple EQS queries in this project, and they become a bit more advanced later on in the series. So yeah, that's pretty much today's video. If you want to get the project files for yourself, you can become a member of the channel or a Patreon, and then you will get access to premium channels in the Discord and also downloads for this project and for the multiplayer game project and a few other things. And if you don't want to become a member, there are also free projects to download, so make sure to check out the Discord. Okay, so let's start today's video. Before we start, there is one small correction from the previous video, and for that we need to go into our behavior tree. So let's open that one up. And for the play idle break animation, we made this variable in here instance editable, but we didn't actually set it. So if we go back to the behavior tree on the right side over here, we can set it in the default panel, and we should set it to -1, so then it will play a random animation instead of playing the same animation every time. So I forgot to set the default over here, so make sure you set it at -1. Okay, so now we have that fix out of the way. I want to set up two functions inside of an interface that we can use for the rotation, so actually the focus of our AI, and also to clear the focus of the AI from the behavior tree. So we're going to create a new interface for that, because I want to use this interface on the controller and not on the pawn. So you don't need to create an interface for every class or actor that you use it for. I'm just doing it for organization's sake, so it's a bit clearer to look at everything. So I'm going to create a new blueprint interface. And we're going to call this one the BPI AI controller interface. And let's open it up. So in here, we're going to add two functions. The first one is AI set focal point. For this one, we need one input, and that's the location of the focal point. So location, and that's a vector. And we also need a function to clear the focus. So we're going to add a second function and call that AI clear focus. And we don't need any inputs or outputs. So let's compile and save the new interface. And we want to set it up inside of the AI controller. So let's go into the controller. And first of all, we need to go to the class settings so we can actually implement the interface over here, BPI AI controller. And then we're going to add the two new functions. So let's start with clear focus. And we can simply drag off and clear the focus. So we can call the function over here. And that's all. And for the set focal point, is it not too hard either. So we're going to drag off and set the focal point. Again, call the function over here so we can plug in the location. Now for this one, I want to add a retriggerable delay. So instead of a normal delay, every time we call this, it's going to reset to the duration over here. So I'm going to set the duration to 1 second. That should give us enough time to play the turn in place animation. And then I'm simply going to clear the focus again. Otherwise, the focus will remain on this point in the level. So just like this. So those are the two functions that we're going to use in the behavior tree later. So we have that set up. And before we start working on the EQS, we want to add a variable in our BlackBoard as well. So let's open our behavior folder and then the BlackBoard. So in here we have the spotted actor location. So that's the location of the player after the AI saw us. And I want to add a second location that is going to be the move to location. So we don't have to override the spotted actor location, but we can pick different locations around this location. So we're going to add a new key, and that's going to be the move to location. And that's also a vector, so that's good to go. Now we can save our BlackBoard. And at this point, we are good to go to start working on the EQS. First of all, I'm going to create a new folder, and in there I'm going to put all the EQS stuff. So let's simply call it EQS. And now we can right click and go to Artificial Intelligence. And in here we have the environment query. So we don't have to go into the project settings anymore to enable it. It's no longer experimental. So we can simply select it in here. So let's create an environment query, and I'm going to call this one EQ spotted actor location. And let's open it up. Now it looks a little bit like a behavior tree, but it works pretty different. So I'm going to try and explain how this works, but to do that, I'm going to create another actor. So we're going to right click, go to the blueprint class. And in here, we want to search for the EQS TestingPawn and select it over here. So we can simply call it EQS TestingPawn. And we're going to use this to make sure that we can see our environmental query in the viewport. So we can actually just add this actor to the level. So let's grab a viewport in here and drop in the EQS TestingPawn. And then in the details panel, we can select what query the TestingPawn is going to use. So let's make sure we have it selected, and then we can scroll down and select the query template. So over here we only have one, so we're going to select our spotted actor location. And then if we look down here a little bit, it says rerun query only on finished move. So this means that after we changed something, we need to drag the actor around in the level, so it will actually regenerate the EQS query. So we're going to turn this off for now. It's a little bit more expensive, but at least we have an updated viewport. So we have the EQS TestingPawn in place. Now if we open up the query on the side over here, we can see what's happening. So let's try and do it like this. So if we drag off the root, we have different options over here. And for now, we are going to work with the point options. So let's select the grid, for example, and you will immediately see something happening. So it will generate a grid of points around our TestingPawn. And we can use all of these points to perform all kinds of tests again. So we can filter out points that we don't need, or score points that we prefer. And that way we can select one or multiple points from this and either move to it or look at it or whatever you want to do. So we had different options for the grid. So for the points option, so this is a grid, it's a square, and then we simply have different shapes. So a circle, a cone, a donut, things like that. So those are the biggest differences between those. And you can set them up over here in the details panel to determine the size of the grid, for example, so you can make it bigger. And then also the spacing between the points. So you can set everything up the way you want to. And then you can also have it project on the navigation data or on the geometry. So there's all kinds of things you can set up over here. So for the post projection offset, you can raise it a little bit, for example, so the points will be off the ground. So that's useful to do. Now let's have a look at this one. It says generate around, and we're going to generate this grid around our querier. So the querier is the actor that is actually requesting this query, and we can change this. So we also have a context as an item. If we select it, you'll see the points disappear. So the item is actually one of these points. So in this case, this doesn't work. But we can also make our own context. So this is called a context. And that's what we're going to do because we want to generate these points at a location in the level. So if the AI spotted a player, we want to generate points around that location and then perform tests against those points. So we need to make sure we get that actor location in here. And to do that, we're going to create our own context. So let's go back to the content browser. And then we want to right click and go to the blueprint class again, and we can look for context. So we want to create an environmental query context blueprint base. So that's pretty much a sentence over there. So let's select it, and I'm going to call this my environmental query. Oh, that was an autosave. Okay. Environmental query context, and then let's make it spotted actor location as well. And open it up. So let me increase the screen. Oh, that was the wrong one. Oh, freaking, I renamed the wrong blueprint. Okay, I'm on fire. Let me fix this. So that was the actual query, and this is the context. So EQC, spotted actor location. We're getting there. Okay, so we're going to open up the context. And in here, we can override 4 different functions. So we can either return a single actor or a single location or a set. So that's an array of actors or an array of locations. So in this case, we want to return a single location. So we're going to provide a single location. And then we can just return it over here in the return node. And we can use the actor that queried the EQS query, or if it is an item, for example, so it's not actually an actor, we can also use the object reference over here. Now for the spotted actor location, we're going to drag off the actor over here, and this is an AI, so we can get the BlackBoard from here. And on our BlackBoard, we have the spotted actor location, so we can simply drag off and get a value as vector. And the key name, we're going to make a literal name. And if we look at our BlackBoard, then that should be called the spotted actor location. So that's simply this variable that we created in the previous episode. So, oh, I don't want to do that. Oh, freaking really. Okay. So I accidentally renamed it, but Control Z and it fixed it. So we're going to paste it in here and then return it. So now we can use this context and that will provide the spotted actor location. But this will present us with a problem if we use the EQS TestingPawn, because the EQS TestingPawn is not running the BlackBoard and the behavior tree, so it doesn't have the spotted actor location. So what we can do for now to make sure that we can keep testing this is simply fill in a location in the level into the return node, and that way we can still see what's happening. So let's grab our viewport again. And let's just pick a location. So for example, if I move my testing pawn over here, so 1640 by 1540, and then this could be 0, that doesn't really matter. So 1640, 1540, let's go back into here. 1640, 1540, there we go. Compile and save. So now if we move the EQS TestingPawn to a different location and then go back into our EQS query over here, If we select the grid, then we can change the context. So now our custom context is in here. So we're going to select the spotted actor location. And you can see it's not generating the grid around our testing pawn anymore, but it's simply using the location that we provided inside of our context. So that's what we want. We just need to make sure we hook it back up if we're going to test this later. So now that we have a grid in place, we can start performing tests against these locations. So if we right click over here, we can add a test. And this doesn't look too impressive, but you can actually be pretty creative with this stuff and come up with all kinds of fun tests and fun results. But we're going to start pretty basic. And the first thing I want to do is make sure that we have a path from the AI to the actual location that we want to move to. So if we cannot reach the location, we don't want to know about it. So we're going to do a pathfinding test. And then with the test selected, we can set it up on the right side in the details panel again. Now let's make sure that some of these points are unreachable. So I'm going to move this cylinder in here a little bit. So now the points should be projected on top of it. No, they are not. So we do need to move our testing pawn around, and now they are moved on top of here. So you can see these are blue and have a 0 score. So they failed the test and we have no score added. And the green ones actually passed the test and they have a score of 1. Now on the right side over here, we can change this. We can either filter them, score them, or do both. So for this one, I'm going to say filter only, because I simply don't care about the points that I cannot reach. So we don't want to perform any tests against these points anymore. We can simply exclude them. So now the points that we cannot reach are blue, and all of the other ones still have a score of 0, because we're not scoring them, we're only filtering them. But they will be included into the next test. So you can also change the bool, for example. So now only the points that are not reachable will be passing the test. So you can specify everything you want to do inside of the details panel to make sure that the test is accurate for your need. So we have the pathing test. Now we can simply expand this with multiple tests, and they will be executed from the top to the bottom. So as I mentioned, we excluded these points. So if we add a second test down here, then that test will only go for the rest of the points. So we're going to right click. And I'm actually right clicking, but nothing is happening. Oh, we want to right click on top of here. Okay. We're going to add another test. And in this case, I want to add an overlap test. So what I want to do here is actually spawn a capsule that has a bigger radius than the capsule of our character. So for example, if our character has a radius of 45, then I'm going to spawn a capsule of 100 radius, 150 maybe. So if that capsule overlaps something, that means it's really close to a wall or geometry or things like that. And then I'm going to exclude those points. So we're going to select the, how is it called? The overlap test over here. Currently it's set to a box. So let's go to the overlap data. And for the shape, I'm going to set it to, well, let's just do a sphere. Why not? It doesn't really matter. I'm not interested in the height, only in the width. So let's increase the width over here. Let's make it 140 units, for example. And now, because this is 140 units in radius, we need to make sure that we raise it off the ground. Otherwise, it's going to overlap the ground. So let's raise it into the air 150 units. And now you can see that only the points that are close to a wall or geometry over here are overlapping, and those are scored. So we want to change that around. We don't want them to match. So now the points that are not overlapping will be scored, and the other points will be excluded because we have a filter and score. So we can say filter only, for example, and now these points will be excluded and the rest will not be scored. So in this case, it doesn't really matter. So yeah, that kind of looks okay to me. So we just erased these points over here as well. Yeah, let's just continue. We can actually fine tune it a little bit later if we want to. So the next test that I want to add is a line trace test. So I want to make sure that if we move to a location, we can actually see the spotted actor location. So it doesn't really make sense if we move behind a wall to investigate the location that we cannot see. So we're going to make sure that from the actual item we can see the spotted actor location. So to make sure that we can test it, we might want to move this cube in here a little bit to block some of the points' visibility. So let's do that. Let's move our player start as well. So if we select the testing pawn again and move it around a little bit, it will update. Okay, so now these points behind here should not be able to see the actual spotted actor location. So let's add another test, right click. And in this case, we're going to add a trace test. So we're going to trace on visibility, but we're not going to trace to the querier because that's the actor that requested the query. But we're going to trace to the spotted actor location. So we can change the context over here. And now we are tracing inside of the floor probably because all of them are still failing and they require a hit. So if they actually hit something, they will be scored 1. So if we go to the advanced section over here, we can go to the height offset. So let's make the height offset 45 for both of them. And now you can see all of the points that are blocked by geometry will be scored 1 because over here it says requires hit. So this will mean the trace actually hit something and we don't want it to hit something. So we're going to disable the bool match. And now all of the points that actually have a visible connection to our spotted actor location will be included and the rest will be excluded. So this is what we want. And again, we could just set this to filter only because we are pretty much only interested in these points. Now a little side note over here, you have to be careful not to add a huge grid because obviously the more points you're going to add, the more intensive it's going to be to test against all these points. But you also have to be careful not to make it too small and then only filter and don't have any results returned. So it's pretty simple to make these tests too accurate or too precise and just filter out any points and don't have a result at all. So it's a fine balance between making it not too big and not too complex, just to make sure that it's actually returning something. Okay, so we have those points excluded. Now the last test that I'm going to add in here is a distance test. So I want to be inside of a certain radius from the spotted actor location. So we're going to right click again and add another test. And that's the distance over here. So we can select it and then set everything up. So we can test 3D or 2D distance if we don't care about the height, for example. And then we want to change the context to our spotted actor location again. So we want to have the distance from the item to our spotted actor location. So let's change the context over here. And then we have it set to range and a minimum and a maximum, but both of them are 0. So let's change them. Let's make it minimum 75 units and then a maximum of about 300. So now we will only get a few points returned. So that's not really ideal. So we might want to increase this a little bit. So let's make this 50 by 500. That looks a little bit better. Let's make it 400 maybe. Let's go in between 450, why not? So now we actually have a few points returned. So also if we move this around and are closer to geometry, we probably are still returning a point. And all of those now have a different score because we have these distance values over here. So they are scored based on the distance to the actual spotted actor location. And in here we prefer a greater distance. So now the points that are the farthest away will get the highest score. And again, we can specify if we want that. So we can change that around if we say inverse linear. Now the points closest to the actor location will be scored highest and the farthest points away will be the lowest. So I'm going to set it back to linear, and then we can also set a target value. So let me check. Is it this one? Let's just try it. So let's make this 300, for example. Yeah. So the reference value over here, now it prefers the points at a 300 range. The ones further away will be scored lower and the ones closest will be scored lower as well. So I'm going to set it to 300 over here, and then we have a reasonable amount of points with a difference in value. Okay. So that's EQS in a nutshell. So as I mentioned, this is pretty basic and we can actually do pretty fun stuff with these tests. So we have the dot test to make sure points are to the side or behind us, for example. We can do fun stuff with overlap testing. So it doesn't look really impressive, but you can actually do pretty cool stuff in here. And again, you can make a custom context and things like that to make it even more interactable. Okay, so for now, we're going to keep it at this pretty basic query, and we're going to set up the rest to make sure this actually does something. First of all, let's go into our environmental query context. And let's make sure that we hook up the return value over here. So we're actually providing our BlackBoard key and not a simple location in the level. So make sure this one is hooked up. And then I'm going to remove the EQS TestingPawn from the level as well. And if we do that, then it will ask if we really want to do it because it also spawned an AI controller for it. We can simply press yes and the AI controller will be removed as well. So that's good to go. Let's make sure we have things saved, and then we can open our behavior tree. And in here, we're going to set it up to use it. So we have our second sequence over here is equal to aware. And at the end, after we stopped all of the montages, we're not simply going to move to the spotted actor location, but we're going to use our EQS query. So let's just disconnect these for now. So we have stop all montages. Then we're going to drag off here and we're going to go to the tasks. Let me see. Oh yeah, I'm sorry. We're going to go to a composite, and first we're going to add a sequence in here. And I want to loop this sequence twice. So we're going to right click on the sequence, and then we're going to add a decorator, and the decorator is a loop. Then with the loop selected, we can simply set it up. So I'm going to say number of loops twice, 2, and that's good to go. Then from this sequence, we want to drag off, and here we're going to run our EQS query. So we can go tasks, and over here we can run an EQS query. So we're going to select this one. With the node selected, we can choose our query. So that's our spotted actor location query. And then over here, you can also determine the run mode. So this will return the single best item. So the sphere with the highest score returned from the test. And we can also say, well, grab the items with the highest 5% score and then pick a random item from that one, or even with the highest 25% score. So we can change the outcome over here a little bit to have it a little bit more randomized. So I'm going to say single best item from the best 5%. And then we can also say the Blackboard key that is going to be filled with this value. So the return value is a location from here. So we want to change the Blackboard key to our move to location. So now the actual return value from the EQS query, so the item that is selected, the location of that item will be stored inside of our move to location on the Blackboard. So after that happened, we can simply move to that location. So we can grab our move to node again, plug it in, and make sure that we have the move to location selected and not the spotted actor location like it was before. So we're going to change it over here to the move to location. Then if we reached that location, I want to make sure that we actually look at the correct direction. So if we simply just move here and stop moving, then there is a chance we are facing the wrong direction or maybe even facing a wall. So I'm going to make sure that we turn towards our spotted actor location. And for that, we want to create a behavior tree task. So we can call the interface function that we created earlier. So let's create a new task, a blueprint based task. I'm going to put it inside of the BTT folder. And then this is going to be the behavior tree task, the AI rotate towards. And I'm actually going to set it up so we can use it in a few different ways. So I'm going to add a few variables. The first one is use actor rotation. Actor rotation. And I'm going to make this bool instance editable. Yeah. And then we're going to add a second variable, and that's the actor key. And we're going to change this to a Blackboard key selector. So the top one over here, key selector, and we're also going to make it instance editable. And then we're going to add a second boolean, and that's use location. That's a boolean. Again, instance editable, by the way. And the last variable is the location key. So let's make it location key and turn it back into a Blackboard key selector again. Oh. And again, this one needs to be instance editable. So all four needs to be instance editable. So I'm simply going to make it, we can either use the rotation of an actor to rotate to that rotation, or we can use a location in the level and rotate towards that location. So we can use this task for multiple purposes. Let's go to function override, and we're going to receive execute AI because we're working with our AI. And first of all, let's make sure we're using the wrong variables. So we're going to grab a branch and check if we want to use actor rotation and not location. So let's make it a little bit fail safe in here. So we're going to grab the use location and add a not boolean to make sure if we have both of them selected in the details panel that it will not mess up entirely. It still messes up a little bit, but and then for this one we can call our AI set focal point on the controller. So drag of the owner controller, and then we have AI set focal point. So that's the interface function that we created at the beginning of the video. We're going to plug this in over here. And then we can get the Blackboard from the actual controlled pawn. Let me double check. We can simply do a right click and then get Blackboard value as an object. So that's over here somewhere as object. And then over here we're going to plug in our actor key. Then we want to cast this to an actor because right now it's an object. So we're going to cast to an actor. Let's turn it into a pure cast. And from the actor, I want to get the actor location and also the forward vector. So drag off the actor again and get the forward vector. And then we can multiply this vector by a couple of hundred units. So say 1000 or 500, it doesn't really matter too much. I simply want to move the location in front of the actor. So let's say 500 units. And we're going to add these together. So now we have a focal point that's in front of the actor that we specified as the BlackBoard key over here. So in this case, that's the rotation that we're going to use. So we can plug that in over here, and then we can simply finish execute. But before we do that, we're going to add a delay over here. So we're going to play our turn in place animation to make sure that we rotate towards the correct direction. And because this is a task in our behavior tree, I want this node to wait before it actually continues executing. So we're going to add a little wait for 1 second, and then we're going to call our finish execute. And we're simply going to make this successful no matter what. So let's enable success. So this is if we want to use an actor as the rotation reference, and then we can also use a location. So we're going to plug in a branch over here, and we're going to double check that we want to use the location. So let's copy and paste this and move it over. Like so. And now we can get a BlackBoard value as vector. So get BlackBoard value as vector. And for this one, we can plug in the location key. And again, we need to get the actor rotation of our own actor. So we can get it from the controlled pawn over here. Nope. Let's drag off and get the actor location. And we're going to do the same thing, but this time we're going to use a unit direction vector to actually calculate the vector that we want to use instead of the forward vector. So we're going to drag off the actor location, and we're going to get a unit direction vector from our actor location to the location that we want to look at. And then we can multiply this vector by something, it doesn't really matter too much. So again, I'm going to multiply it by 500 to move it in front of us a little bit and add it to our actor location. So drag off the actor location again and add them together. And then we can use this as a focal point. So again, we can call our AI set focal point over here. Plug this one into the true pin. Return the location, wait for 1 second, and then finish execute. So that should be good to go as well. And now what we could do is go to the false pin over here and then grab a finish execute again. And for this one, we're going to say it failed. So then at least we have a little bit of a failsafe. And for this AI set focal point, we need to hook up the controller as a target for the interface. So let's make sure we don't forget that one. Compile and save. Okay, so now we have a task that we can use in our behavior tree. So let's drag off here again. We're going to add a task, our AI rotate towards. And in this case, we want to use a location. So let's enable the use location boolean, and then we want to rotate towards our spotted actor location. So select that one from the list over here. And that should make the AI rotate towards the correct spot in the level. So after we did that, I want to play the idle break animation where he's looking around. So I'm going to call the idle break over here again, drag off, go to tasks, play idle break. And for me, I'm pretty sure index 0 is the one where he's moving around and not the one where he is fiddling with his weapon. So I'm gonna simply set index 0 over here, so it's not random, but you can do whatever you want. You can play the other animation, make it random, do whatever you like. And then I'm simply gonna add a wait over here, so a task wait for about 5 seconds. So this idle animation is about 4 seconds. And then he's gonna make a second loop, so he's gonna pick a second location around our spotted actor location. Again, move to that, rotate towards the spotted actor location, play another idle break animation, wait, and then this loop is done because it looped 2 times. So after this, we want to actually continue our logic, but we're not going to do that at this point. So right now, I'm simply going to hook up this wait again. So at the end, we have another wait, and we might want to increase it a little bit. There we go. So this is going to be our behavior tree for now, and I think we should be good to run a little test. So hit play and let's see what happens. If we move close, the AI is going to spot us. So we want to make sure the bar fills up, and he's going to investigate our location. So then we need to get out of the way, otherwise we're going to trigger combat, and that's going to block everything else. So he's moving towards a location around me, and then rotated towards it, played the idle break animation, and then picked a second location. So it seems to be working. And right now things are going to stop because at this point we actually didn't add any other logic. But it actually seems to be working, and we can also do our EQS query over here. So if we enable the gameplay debugger, we can enable the EQS class, and then we should be able to see the EQS query over here, and we can even see all of the points that it's querying. And if we look at a point, we will also get information about that point, what tests it failed, what score it got, things like that. So you can also see EQS inside of the gameplay debugger. So it's actually still running because we added the 10-second wait at the end of the behavior tree, and then it's going to rerun the EQS query. Okay, so this is actually working, and because all of this AI behavior stuff is running on the server side, we don't have to worry about replicating this other than what we already did inside of the pawn and the controller. So this is going to work multiplayer as well. No. So for example, let's move out of the way a little bit and then have the client walk into the side range. And he's simply going to investigate that location. And as you can see, everything replicates. So the idle animation, the move to, all of that stuff is actually working. So that's the first little touch on EQS, and it's actually a really fun feature to play around with and actually make all kinds of fun stuff. So we're definitely gonna get back to this later in the series, and I hope you enjoyed it for today. If you did, please consider leaving a like, and I'll be back soon for more. Later guys and girls, bye bye.